Welcome back for the lecture series on laser physics and their applications under Swayam portal. Now we are dealing with variety of applications of laser. Particularly, first part I am focusing on the diagnostic applications of laser. The diagnostic applications of laser means when you shine a laser beam on an object, the laser beam carries only the image or information or changes in the phase or in the amplitude without actually damaging or changing anything on the object. This is called the passive application, or in general we say as a diagnostic applications. Why I say diagnostic application? Already I have indicated one such application is detection of cancer using laser beam. I would repeat it again because that is a very big value research. Before we go to that, let us focus right now on holographic technique. Coming back to this one, holography, I have told you from 1960 up to 2000, it was the most important fascinating applications in the laser field. In that particular time, it has done its best because holography is a big business tool, big business art. It is an art and also a science. The art and business part of holography, I would mention it. Now, imagine if I could take a three-dimensional image of a person. Just imagine three-dimensional image of a person, then it becomes a lifelong preservation of a real life man, alive man. Even if the person is dead, everybody should die. Even if the person is dead, you will see the real three-dimensional real man or real woman in real life like condition using holography. That is the beauty of the three-dimensional photography. Allow the person to stand there, sit there, and let him do whatever. He can even walk. No, we do not care. Imagine somebody, a beautiful dancer, is dancing it at some point. All that we need to do is have a neodymium YAG laser, preferably, or the best one is 532 green. You start with the 1064 neodymium YAG laser, put a second harmonic generator. How to produce second harmonic generator, I will come back later. It will produce double the frequency or half the wavelength, that will be 532, will be a green light, it will be a pulse light. So, what we get is a powerful coherent laser in the green at 532 nanometer with the pulse width of 10 nanosecond. That is, the pulse will last only for 10 nanosecond. That is all what we want for taking pulsed hologram, to take the different nuances of a dancer, a real dancer, and what we are going to record is a real three-dimensional image of a real dancer. That is what we are going to do. So, it is an art, that is all. Then all that you have to do is just start with the laser, split up into two. One beam comes here, put another mirror. This particular beam falls, this is the reference beam, this falls on the dancer, the full real dancer, because I can put a lens which can expand the beam into 6 feet height, no problem, 6 feet height and 2 feet or 3 feet width, that is all what we need. You have variety of lenses, that is done. So, that is a reference beam. Another one is another part of the beam just is allowed to fall on the dancer, that is all. Now, these two beams are going to interfere. First, allow her to keep standing, do all the adjustment, then run the laser, let her also do the dance. Then what will happen is, you will have shot by shot number of shots coming on the person. Now, what we need to do is, if you give a proper time delay between one pulse and another pulse, you will see one pulse, only one pulse getting split up, going there, another pulse going there, then these two will produce interference. You have a holographic plate. It will record the three-dimensional image of the nuances of the facial expression and the hand expression of a real person, a real professional dancer. One, done. Then next, turn the holographic plate. Remember, just listen, turn the holographic plate. Send another shot. By this time, the lady also would have changed her position, changed her facial structure, facial expression or movement of the hand. Take another shot. Like that, keep on doing at proper time interval, synchronize it. After some time, you don't have to bother. Allow her to do free dance, allow the laser to come in a free repetition mode, allow the holographic plate to move in certain fashion, automate everything. It's all possible. Then you will be able to get a complete three-dimensional photography of a professional dancer, live dancer at the height of 5.5 feet. Real person you can see. If you carefully adjust the camera, everything, you could see the facial expression also. So, this is called the pulsed hologram of a real dancer. It has been done. It has been done in certain particular fashion. It was all exhibited in so many museums once upon a time. Okay. To do again for a reconstruction, you need a laser, because what you have seen, this is called just transmission hologram. Why we call it a transmission hologram? I must say, I must show this picture. In this picture, you can see the laser light is falling on this and you get reflected, and here another one. The light has to go through this one. This is what we call the image. This is the typical example of a transmission hologram. The whole thing, instead of stationary, becomes a pulsed hologram and the object is moving. This is also possible. Now, what is next important is, can we take something called reflection hologram or color hologram? That is also is possible. In this case, what is happening is, you can have a laser. You need a laser of 3 colors at least: blue, green. The 3 primary color lasers are available, and the holographic plate should be thick, about 25 micrometer thick. That emulsion thickness should be there. Then same object, first shoot it with blue, green and red. So, you use 3 lasers, shoot with that one after another, or you can use all the 3 together. Then under this condition, you will have a volume hologram. You will have a volume hologram. When you have such a volume hologram, do all the regular process of whatever that has been done for conventional holography. When you take it, that object will take it out and show under an ordinary bright light like this. Then, since the white light has blue, green and red, all the 3 colors are already there, this is capable of reconstructing the image, and that one such thing is this. You can, if you look at carefully here, if you look at in this one, later we will focus and show you, this has the reflection of Tamil Nadu symbol. This is a driving license, and this carries the beautiful symbol of Tamil Nadu. This cannot be duplicated by anybody else. That is the advantage of this one. So, this particular label, this label is a very, very thin film. This one is best typical example against counterfeit. You know, people make a rupee note, dollar note. You can produce any counterfeit for any object. There are professionals in that line. Now, to prevent such kind of fraud, this anti-counterfeit measure is important for any product these days. Listen carefully, these days throughout the world. Dollar, pound, francs or any rupee note, any kind of currency, any kind of valuable material, valuable certificates will carry a beautiful holographic label. That holographic label will contain the image of the object exclusive to that owner. That way you preserve the originality and the quality and the value of your product. This has become universally accepted, and that is where only then people have realized what is this one, and that is one of the biggest advantage. I mean, this label, holographic label, is a one which popularized laser throughout the world. Okay, up to now I have been telling you only about the art of this one and business aspect. There is another thing, very interesting aspect, that is called holographic interferometry, which is purely scientific technological importance. This again I can explain. It is like this. Okay, correct, we will come back. Now, this is a very great example of holographic interferometry. In this case, we want to see the stress pattern and the capability of withstanding of a big turbine blade under a big stress like a wind. What it means, let me explain. You have, you have airplane which has a big wings and it has a big blades. Now, when it is flying up, when there is a tornado or any big turbulence, the blades will undergo certain type of stress. Now, under the stress, the wings of the flight or the blades of the flight will undergo big changes in the configuration. Now, if you want to see how good is the product after all the manufacture, put them under this holographic interferometry test. This is an important non-destructive testing. How do we do that one? Very simple. Go back to whatever I have just explained earlier. Same thing. In the object, you put the turbine blade. Take first exposure. Then, without changing anything on the object, you give a stress. For example, if you take a big metal plate or the turbine plate, first put the turbine blade, take the first shot, then give a stress on the turbine blade by putting a weight left side and right side. Because of the weight that you added, this will undergo certain distortion or stress. The stress pattern, now under this condition, just give one more shot, one more exposure. This is CW laser. We are doing the conventional holographic technique, not the pulsed one. Under this condition, after giving the stress, take one more shot. That means the holographic plate has not been moved at all. It has been kept stationary. Only thing is, between two exposure, the object alone has undergone certain changes in the stress, certain changes in the configuration. Under that condition, take two shots. Then do all the conventional process or whatever we do. This is called double exposure holographic interferometry. Such a double exposure holographic interferometry pattern is shown here. For a blade, you see, before any stress, it has certain pattern. After producing different type of stress, you see the changes in the configuration. The nodes and anti-nodes are totally different. This is for double exposure holographic interferometry. You can see on the top and the bottom one, This is called a time average holography. The bottom one is called time average holography. The only difference is in the first one, the top one, you have taken a blade, a turbine blade, before X stress, another after stress. That is called double exposed holographic interferometry. Whereas the bottom one, you take the same blade, allow it to vibrate. When it is vibrate, see the vibration at the different hertz, different frequency, low frequency, high frequency. For example, in this example, the first one is vibrating with the 983 hertz, the second one is vibrating with 2 times the frequency. Because of this one, you see the different pattern changes in the pattern that represents the deformation undergoing, the deformation that the blade undergoing under different vibration. This is of great value, engineering value, and this is a great application in aerodynamics. I would show some of the volume holograms, reflection holograms in the next few slides. With that, we would have covered the essential features of holography and holographic interferometry. To sum up, there are only 2 types. The conventional steady state holography, where helium ion laser is the best, and that will give a real lifelike picture of any object which is kept fixed. If you want a holographic label, the best one is 3 color laser, one after another simultaneously, that will produce a holographic or a volume hologram that will give construction using 3 lasers, reconstruction image observation using ordinary white light, sunlight or ordinary bright mercury vapor lamp, because the white light contains anywhere blue, green, red. So, you will be able to see this one. This is the best for anti-counterfeit mission, and this is used throughout the world. The third one for engineering aspect is double exposure holographic interferometry or time averaged holographic interferometry. Those are very specialized engineering applications. I do not want to go beyond this one. Another important application is holographic grating. I want to know what is a grating. It is just a very important application, useful for variety of educational research purpose. A grating is something like this one. You see the 4 fingers, it has a small opening and obstruction. So, a grating is a number of lines drawn on a transparent plate. Usually in the olden days, they had a very clear, what I would say, there will be a clean plate on which they would draw lines using a sharp diamond needle. Then all these needles, all those lines will not allow the light pass through. Ordinary glass will allow the light pass through. That means it becomes a plate with obstruction and opening, obstruction, opening, obstruction, opening. This is all the grating. Next point, up to this is a very old story. Up to 1960, people were able to make grating with usually 6,000 lines per centimeter. That is a typical value, 6,000 lines per centimeter. If you are really professional, you can go up to 7,000 or 8,000, up to okay. Beyond that, it is almost impossible to draw lines using a sharp needle. So, that was the limit with which people worked it. If we have more number of lines, the resolution of observing any object increases with the number of lines drawn on the grating. This is a standard theory in optics. Greater the line, greater the resolution of the object. If you do not understand, I can give very good example. when people do all kind of building construction, they will bring the sand from somewhere and they will do sieving. Why they do sieving? They want to take the very small, very fine quantity, fine type of sand alone mixed with this cement, and then they mix it a certain part. To do that, they have to filter it so many times. First part, second part, third part. You just see anywhere, go to any kind of building construction, you will see that one. Then the first filtrate, second filtrate, third filtrate, the finest filtrate you will get only when the holes are very small. Only through that you will get very fine sand particle. They have certain application. The gross one, gravel like that, we have it as another application. Now, if you want to get the best, finest quality of sand, you need very small hole. In a similar fashion, if you have large number of lines in the grating, you will have a very good resolution between two objects which are so close together. If you could resolve them into two different parts, that is called the resolution. This is very important in optics. In fact, optical microscope, and then people start with optical microscope of 10x, 100x, 1000x or 10,000x. That means it will enlarge 10,000 times. After some time, people went for electron microscope, where the wavelength of light, wavelength of particle interacting, that is the wavelength of electron beam, is so small that even very small tiny object can be resolved, can be seen well with the magnification of million. That is the purpose of seeing scanning electron microscope. Now, such a very similar thing, we are using a grating with large number of lines. A grating with large number of lines can resolve, can be a very big help in a spectroscopy. Now, once the laser came, people thought about this one, and then they have started making holographic grating. How do you do that? Very simple. I have shown you this one. You start with the laser, put a mirror, allow 50% of the light to fall on a holographic plate. Another 50% of the light fall another mirror. These two beams interfere on the holographic plate. Then, depending upon the angle of interference, you will have number of fringe pattern. Adjust this line such that you can have let me say 12,000 lines per millimeter. Now, this is 10 times higher number of lines are available in holographic grating. If we have 10 times more number of lines available, you can resolve two spectra with very closely spaced lines. So, this holographic grating has been of very great value in laser spectroscopy or any conventional spectroscopy. And how do you use it? I have shown you the next line. Take a holographic grating, put there, send a laser beam, you will get +1 order, -1 order, 0th order also will be there. If we have more and more number of holographic lines, most of the light will be in +1 or -1. You cannot have more orders. The lesser the lines, more the orders, and the energy will be distributed everywhere. If you have more number of lines, most of the energy would be concentrated in +1 or -1, and that will be resolved also. That is advantage. This is one of the important applications of holography, and this has pushed the resolution limit of optical microscope and optical spectroscopy to enormous extent. By way of conclusion, let me recollect whatever I have told you in the last 1 or 2 lectures, particularly on holography and its application. Holography is essentially a 3-dimensional photography, lensless photography, terrible photography, that is what I always say. and this is possible only when you have a coherent light. We need a coherence of about 10 to 15 centimeter. The best one is helium-ion laser. Once upon a time, I was telling you, for optical communication, semiconductor laser is the best, and the reverse also is true. The semiconductor laser has no other application than optical communication. So, they are made for each other. In a similar fashion, now in these days, holography needs Healy laser. Healy laser is best suited for holography, or for helium-ion laser has lost its flavor. Once upon a time, it was the most favorite one. It has the best application in holography, and for holography, Healy is the best. They are made for each other. Here, you can use holography as an art or as a business counterfeit, anti-counterfeit tool. This is where both it has one enormous application, and also as a pulsed hologram, it has been able to preserve the real life like a human being. That is something unimaginably true. Another very interesting application is holographic interferometry, which has a technological engineering application, particularly for aerodynamics. I have been able to sum up all this one. We shall see more and more applications later. With this, most of the diagnostic or passive applications of lasers are done. Thank you very much.